couple questions. I've been really enjoying the conversation so far, by the way.
Likewise, has to prove that in that black box, the link still stays, right?
Yeah.
That's,
Got it.
yeah.
Um, I guess real quick side tangent off of that. Do you work in a virtual setting with folks who aren't in your immediate area for folks who want to reach out?
Um, I have not yet figured that out.
Okay.
And the reason is legally, as far as I can tell, and I'm not a lawyer, but I try to understand the law as best I can.
Sure.
I am held to the standard of my highest training. So I am an internist, and I'm held to the standard of an internist. And so it's not clear to me how I could do longevity consulting without having a medical license in the state that the person's in.
Mm-hmm. Okay.
I think there's a way because I see other companies doing it, but I actually don't know what legal thing they're doing to get around that. Um, so I haven't done it yet, but I would like to.
Yeah, I'm interested in looking at that too. I know I talked to like the CEO of a company called Wild Health, and they do, I think, exclusively virtual care,
Okay.
and they have physicians, licensed in all 50 states for the
Right.
type of health that they're doing. So, yeah, I'm not sure if there's like some sort of simplified process for getting licensure across all states, or I'm sure you
So
into
not
that.
all states, there is the IMLC compact, which will speed up getting a license in
Majority.
different states. I would have to maintain a bunch of different licenses, and it still wouldn't be all the states. It would just be the IMLC states. But I am actually looking into that specifically for that reason. So yeah,
Okay.
working on it. But
Interesting.
it's a lot of money though. You're literally paying for an individual license. It's like, okay, that's
Yeah.
300 a month for that state and 200 a month for that state, and you're kind of it's if you don't have any patients there, it becomes kind of weird to do. But
Is there any way to help a patient outside of like a physician to patient relationship where you would need licensure? I mean, I've
yeah, so the real crux seems to be, and again, I'm not a lawyer. I'm just trying to
yeah,
figure this out myself.
sure.
So I could be totally wrong on these things. Maybe I'm overcomplicating it, overthinking it. Your audience can probably tell that overthinking is not foreign to me. Um, but I think the key is whether a doctor-patient relationship has been formed. And so uh, I do think there are ways where, and one of the things I want to do is start training non-physician people to do some of this data gathering, do a VO2 max,
Mhm.
do a straight, the technology has gotten to a point actually where we could pretty much ship you a package with
Mhm.
a device that measures your VO2 max,
Oh, you're
give you
already
the
on that.
protocol,
Yeah.
and like you send us your data and we'll analyze it, right? And I think there's enough cardiologist look at an echocardiogram or a radiologist looks at a scan and they're not forming a doctor-patient relationship. So I could look at the data and give you recommendations and we wouldn't have formed a doctor-patient relationship, right? Um, so that may be one way around it. I'm kind of trying to explore that idea. Um, but yeah, I have had people too. I mean, it's a pretty high end practice, so people are fairly wealthy. I have had people that live out of state,
Yeah.
and they fly in once a year for their data gathering, and then we do everything else remotely. And so that's also a viable sort of package where um, just it's once a year, and for a lot of people that's not a huge deal.
Yeah, I only ask because yeah, I can just imagine how many people could be benefited by not
Yeah,
only
yeah,
the medical side, but everything we've been talking about so far,
totally.
meeting span. So yeah, definitely interested to stay in touch and see how that progresses, and hopefully there can be things that I can do to help support that through my
No,
network.
yeah, amazing. Oh, by the way, I forgot about this. I've also started offering just the data gathering with 1 month of telemedicine follow-up. So
Okay.
you don't have to buy the whole year. Because I did get a bunch of interest on people that just wanted a month. And there's no
Okay.
way to get into the meaning and purpose stuff, but the
Mhm.
longevity optimization stuff at least, we
Yeah.
could do and get you an assessment uh, on the top 5 factors and kind of see where you're at. So I also offer that.
Cool. That's good to know. Thank you. And I wanted to be respectful of your time because I know we've gone a little bit more than at least what the calendar invite was. Are you okay
Oh,
for
totally. Yeah, totally. My next patient's at 3, so I'm pretty got another hour if you want to do it. Uh,
because I wanted to kind of circle
yeah,
into just a couple questions. I've been really enjoying the conversation so far, by the way.
likewise. Yeah,
But I've watched some of your content pushing back on some of these ideas being put out there by, longevity clinics or
sure.
influencers in the space, which I really appreciate that you're doing that. And I wanted to kind of dive into a couple of those questions around.
Yeah,
I know there's a lot to unpack when it comes to the statistics and the math of false positives with screening and diagnostics. So we've got a whole video that does that beautifully.
sure.
But I think just from a high level, curious to get your take on this phenomenon of like, we'll run 200 blood biomarkers for you instead of,
Yeah, yeah, yeah. Yeah,
just
totally.
kind of overdoing it.
Yeah, I mean, I get the impulse. I really do. It One of my favorite principles, you probably came across this in my videos, is Brandolini's principle, where he says it takes 10 times the amount of time, energy, effort, and knowledge to refute bullshit that it does to generate it, right? And that is challenging because, you know, it's easy to say, oh, hey, we're going to run these 200 biomarkers for you, and they're correlated with longevity. And if you optimize them, then you're improving your. Now, refuting that, I have to go biomarker by biomarker. It's easy to make that claim, right?
Mhm.
But in
Yeah.
order to refute that claim and to say why it's wrong, I have to go one by one through. I have to show the studies. I have to teach the notion of correlation is not causation, right? And so then then I pull from certain, I'm sure you've come across my homocysteine example, right? Great correlation, correlates very well with mortality, longevity, cardiovascular disease, dementia, all the things, right? It can be lowered easily with B vitamins, but when you do a placebo-controlled randomized trial of B vitamins versus placebo, you do lower homocysteine and there's no effect on mortality. It's an innocent bystander, it's a marker, it's not in the causal chain. And so you can very well, with a lot of these biomarkers, be optimizing something that either doesn't matter, or, and here's the really crazy part, is what if you're de-optimizing? What if that molecule being high is your body's compensatory mechanism for something else that would be worse without that compensation, right? And so you have to actually kind of you have to prove that you're optimizing longevity when you say you're optimizing longevity. You have to do a, a double-blind, placebo-controlled study and prove it, right? Um, and so yeah, I think I get the impulse, I get the desire. It I think a lot of it comes down to we're used to computers now. We're used to um, physical objects of in the world, and biological systems just work so differently that
That's a
I think a lot of people, and some of my best friends are in tech, and when we first met, this was probably the thing that got them jumbled up the most about like what I do. Is they're like, how do you operate in an environment where there are no linear correlations at all? Like, there's no one-to-one mapping of anything. It's always many to many, right?
right.
And the only way to do that is to do overall trials and say, okay, if you take a statin for 5 years or 10 years, what is the actual reduction in mortality? Not, oh, hey, this lipoprotein is correlated with mortality and statins lower this lipoprotein. And therefore, without doing the study, we can assume that there's a mortality benefit. That assumption doesn't work because it's always a many to many mapping, not a one to one linear mapping. You have to operate in many ways as if the biological system is a black box. And
Mhm.
if you really deeply internalize that all biological systems are black boxes, you you will look at things differently and you'll start to think correctly about these biomarkers because it's like, oh, biomarker, black box, mortality. Oh, okay. Well, then something has to prove that in that black box, the link still stays, right?
Yeah.
And that's the simplest way I can say for people to overcome that is to just realize that there's a black box there.
I got it. Yeah, a couple of follow-up questions off of that. The first one is, do you think, and it's hard to predict how things are going to develop, but do you think with advancements in, I mean, the theory here is that as advancements in AI are going to bring clarity to all these complex interactions and be able to create better predictive models that, again, we still won't really know until you run like a placebo-controlled trial on a lifespan, which is
Right.
very possible to
Very
do.
difficult.
Yeah. So do you think that will be the case that will move the needle significantly by implementing AI? Yeah, I guess we'll start with that question.
Obviously, I don't know for sure,
Yeah.
right?
Yeah.
I tend to be a bit more of an AI skeptic than I think most people are. And part of the reason is this, even pre-AI, I don't think we were short on hypotheses. I think we had a number of good hypotheses. We're short on placebo-controlled randomized trials, right? Because everybody wants to do an observational, retrospective, let me just look at the data set trial because it's quick, it's easy, it's cheap, and you can get your PhD doing it, right? Doing a placebo-controlled randomized prospective trial is expensive, big, and challenging, and we already were short. I think AI will help us come up with hypotheses, but we weren't struggling to come up with hypotheses before. We're struggling to eliminate hypotheses by doing placebo-controlled trials. Um, Now, the real question is, will AI help us come up with hypotheses that have a better pretest probability of being true? Um, and I don't think so, but the reason for that gets a bit complicated again. Um, so one of my favorite examples of this is just simple. Is you know those the bouncy balls, the
Yeah.
rubber like bouncing balls? Um, the physics of those are interesting. If you throw one and it bounces, you can very easily calculate that first bounce, right? It's simple physics that we all learned in college, right? Or whatever,
Yeah.
high school physics. The second bounce is more complicated because now you have spin that's interacting with the air in certain ways, right? The third bounce gets really complicated because now the material of the rubber as it interacts with the surface becomes important because it's spinning plus the air, right? By the fourth or fifth bounce, you have to start accounting for the gravitational pull of people in the room, right?
Hmm.
By the ninth bounce, you'd have to know the position of every atom in the universe,
Wow.
right? And so biological systems are kind of constantly operating on that ninth bounce, right? So you can come up with some ideas and theories, but the level of complexity so quickly escalates exponentially that it becomes, in computer terms, computationally irreducible, right? And so, for I don't know how many of your audience are into chaos theory and complex mathematics, but mm, or actually a simpler example is the game of life. Are you familiar with the game of life?
I'm not sure.
Okay,
Don't
so
think.
it's a computer simulation, empty grid. There's a cell that's a different color, right? So
Okay.
that's an on cell. That cell is alive. And then there are certain rules, like if a cell is surrounded by four dead cells, then those four cells become alive. And then, or whatever. You can set the rules of the game in different ways, and you end up with these patterns, is that you run that simulation, and then the pattern of life kind of emerges, right? Um, and the interesting thing is with very, very simple rules, you cannot predict what the end result is. It becomes unpredictable, computationally unpredictable very, very quickly, right? And so that's why I think AI won't help as
Okay.
much as, sorry, that's too strong. Won't help as much as the AI proponents are hoping it will help. Um, I do think it will help in some ways. So I think protein folding, for instance, is a huge advancement. I think that's been an open problem in biology for a long time. Um, and I think that it's been amazing. AlphaFold has figured out how to predict protein folding structures, right? To give an idea of the complexity we're dealing with, though, there are a lot of proteins that do not have folded structures, right?
Mm.
And AlphaFold can't help there because the protein fundamentally is not structured, right? So we don't know how it's doing its work. Like it's doing something, but it's doing it in an unstructured way. And you're like, well, shit. like, you know, I don't know, right? And so or we have this idea that DNA goes to RNA, RNA makes proteins, right? Unfortunately, which parts of DNA actually gets transcribed into RNA is determined by a lot of different environmental inputs. The RNA is spliced into multiple different types of RNA, and which direction it gets spliced depends on the environment in multiple different ways. So a single strand of RNA can create up to 150 different types of protein depending on how it's spliced. And so the predictability just isn't there. You can't just say, "Oh, I see this genetic code and that has again, there's no one-to-one mapping." And without a one-to-one mapping, even AI, yes, AI is great at pulling out correlations, right?
Mm.
And correlation is the first step to causation, right? But you're not going to get there any better. And I would argue actually that our pre AI computing pulled out the big correlations. Like it's easy to see the correlation with VO2 max. It's a 5x difference. It's not hard, right?
Yeah.
Will AI help pull out 0.0001 correlations? Sure. Sure.
Mm.
But do those really matter? Like is that like we haven't figured out what to do with the 5x correlation. like, you know,
Right, right.
and so I think our pre-existing technology was good for the big things. AI may help us find small things, but we already were kind of like drowning in small things, and I don't know that it'll matter that much. So everything I just said about biology, right? About the complexity, you can put science as a whole there, and the same thing is true, right? I don't know how science will evolve. I don't know what correlations, what causations we will discover.